Hello, math students. Today we are going to talk about dilations some more, and we're going to focus more on the scale factor part of dilations. So, the two different types of dilations that we have are reductions and enlargements. So, if a scale factor is less than 1, so it could be written as a fraction or as a decimal. If it's less than 1, we're going to get a reduction. Now, be careful. I said it could be written as a fraction or a decimal. Remember, some fractions are actually more than 1. So if you had a fraction that was, let's say, 6/5, that's more than 1. That would be an enlargement. So we have to be careful there. So if a scale factor is greater than 1, more than 1 would be an enlargement. Now, again, it might be a whole number or it might look like a fraction as long as it's more than 1. I want you to notice though, we don't have a scale factor that's exactly 1 because multiplying by 1 wouldn't change anything. So to get a dilation, that scale factor either has to be more than or less than 1. It can't be exactly equal to 1. So for this problem, we are going to graph the dilated image. I already have the graph here. And we want to get a scale factor of 3 for the new image. The origin is the center of dilation. I said that's what we're always going to go with. I would suggest that we start by getting the original ordered pairs because getting a scale factor of 3 just means multiply everything by 3. So point M is at 1, 3. N is at 3, 2. O is at 2, -2. And P is at -1, 0. When we use a scale factor of 3, again, everything, the x's and the y's get multiplied by 3. So M prime, instead of being at 1, 3, would be at 3, 9. And N prime would be at 9, 6. O prime is going to be at 6, -6. And -3, 0 is going to be P prime. Now notice the 0 part didn't change, right? That's what happens there. So 3, 1, 2, right there at the top, that's going to be M prime. O prime, I'm sorry, N prime would be at 9, 6, right here. O prime is going to be at 6, -6. And P prime is going to be at -3, 0. So then we should connect these. Again, on the board, it's not always the easiest thing to get nice straight lines, but you can certainly use a ruler. And I want you to notice, in theory, this looks like it's basically the same shape. Remember, the way that you can check this then is to draw from the origin through the original point. Oh, wow, I totally missed that one. And the prime, remember those primes are really, really important so that you can see which one is the original or the pre-image and which one is the new image. So if I have this shape this time, and I've got a scale factor of 1/3. 1/3, multiplying by 1/3, you know, is the same as dividing by 3. But again, let's get our original ordered pairs listed here. So M, I'm going to first pick up my marker. M is at 3, and we figured out the top is 9 on that one. N is at 6, 0. O is at 3, and I think that's -6. And P is at -3, 0. When I have the scale factor of 1/3, again, that's the same as dividing everything by 3. So 3, 9 would go down to 1, 3 for M prime, and then 2, 0, 1, -2, and -1, 0. And then we graph that. So 1, 3 right here is M prime. N prime is going to be at 2, 0. O prime is at 1, -2. And P prime is at -1, 0. So here's this shape, much easier to draw when it's so much smaller. But again, it looks like the same shape. They definitely look similar. You could still check this by drawing lines from the origin through the pre-image and the image points. As long as it all lines up, you know you did it right. Okay, a scale factor of 1.5, I know might kind of bother some people. Notice this one says using 0, 0 as the center of variation. That's the origin. Again, that's the same point that we always use. So point X is right now at -4, 2. Point Y is at 6, 0. And Z is at -2, -4. If my scale factor is 1.5, now, first of all, you know you can use a calculator, just multiply everything by 1.5, that's fine. If you want to do this in your head, you find half of each number and just add it on to the original number. So for letter X, to get X prime, -4 times 1.5, well, -4, ignore the negative for a second. I know it's going to be negative. Half of 4 is 2, add that on, that's 6, so that's going to be -6. Half of 2 is 1, add that on, we get 3. But again, you can certainly just use a calculator for this if you'd like. So those are our ordered pairs just by doing our multiplication. -6, +3. So it is bigger. It's an enlargement because it's more than 1, but it's not like doubling the size. It's only taking it 1.5 times as much. And Z prime is going to be at -3, 2, 4, 6 right here. There we go. Okay. In this problem, I want to be able to decide what kind of dilation is graphed on here. And again, the primes are so important on this because that's how I can tell this is my new point P, this is the original point P because of the prime. Because my new shape is smaller, I know this is a reduction. And to find the scale factor, remember we talked about this in the last lesson, but the scale factor is always going to be the new over the original, right? We usually use K for scale factor, but the scale factor here, I have two options. Either I can count how long this vertical piece is with the vertical piece that matches it. Certainly welcome to do that, and I will probably do that as well. But you can also just take one point, one pre-image point and the new image point and see what it got multiplied by. I'm actually going to use M and M prime because those are kind of the nice small numbers here. Point M prime is at 1, 1. And the original M is at 3, 3. Just by writing that, you can see that it got smaller. First of all, don't think that the scale factor is 3. The scale factor is 1/3. All of the numbers got divided by 3. I can take the X or the Y. They happen to match in this case, but I could take this and this as both X's. Using my new over original, the new X value was 1. The original X value was 3. Said everything got divided by 3, right? Now, if I take a look at my segments, I would have 1, 2, 3, 4, 5 for this length. This one is, I'm going to go 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that new over original also would give me that same scale factor of 1/3. Just make sure you're always putting the new value, X value, Y value, or length on the top, and then the original goes in the denominator. And again, a scale factor of 1/3 makes sense for a reduction. It had to be less than 1. You don't have any problems like this exactly on your worksheet, but I think that this is a valuable thing to be looking at. These are similar, which means that they're actually proportional. Not that we've really done much with proportionality at this point, but if I'm going to go from figure A to figure B, I want to decide, first of all, if it's a reduction or an enlargement. If I'm going from A to B, it's getting smaller. It's clearly going to be a reduction on this one. And to find the missing length, to go from 18 to 9, it's cut in half. The scale factor is 1/2. So half of 16 would give me 8. Okay, we're going to just do a couple of those quickly here. On the left, A to B is getting bigger, which means that it's an enlargement. I didn't specifically ask for the scale factor, but I said it on the last problem was 1/2. This time to go from 6 to 42, that's multiplying by 7. My scale factor is 7. Much bigger than 1, that's why it's an enlargement. So if I multiply by 7, just takes 9 times 7, and I'm going to get that x equals 63 for a side length. On the right side, don't get confused because of the order. I'm still going from A to B, because the A is the bigger one and it's going to a smaller one. That is a reduction. And I would say, just using some common sense here, do you notice that both of these are exactly the same? So then the sides that match, the corresponding sides, if this is 20, x is also going to be 20. And we could talk about the proportionality as well, but again, you're going to have two sides that match because that was an isosceles triangle. In these problems, if I'm giving you a pre-image point, like the original point, and the new image, I want to know what the scale factor is and what kind of dilation it is. So without seeing a graph, we should be able to make these determinations also. Looking at A, to go from 4, -2, then A prime is 12, -6. Well, both of those numbers are getting multiplied by 3, right? So that means that my scale factor is 3. And since that's more than 1, that's going to be an enlargement. For B, to go from 7 to 3.5 might kind of throw some people off a little bit, but let's focus on this one. To go from 10 to 5, it's getting cut in half. Multiplied by 1/2, divided by 2, the new over the original, 5 over 10, the scale factor is 1/2, which means it's a reduction. In letter C, to go from 8 to 6, some people would be kind of freaking out right now and saying, I don't know what I multiplied by. To go from 12 to 9, that's not a whole number. That's okay. Let's use our scale factor knowledge. We're going to say new over original. So let's go with the 6 and the 8, which can simplify to 3/4. And you can see the numbers were getting smaller anyway, so you should have known that it was going to be a reduction. All right, and for letter D, move this up just a little bit. To go from 15 to 10, again, maybe you can see what that is. It is getting smaller, which means it's going to be a reduction. But if I pick the x's or the y's, it doesn't matter, but I want to go new over original. So I'm going to have 10 over 15, which is 2/3. So also a reduction. Okay, so today, your worksheet is the dilations worksheet, but again, a lot of work with scale factors. The answer key is in Schoology, just like always, and today you're going to be doing a paper formative in class, reviewing some stuff with rotations, but also working on our stuff with dilations. If you have any questions, let me know.